Welcome to the GIS e-learning Module 3 on Symbology and Geovisualization. Recapping from what we learned in Module 2, GIS is an open-source application that anyone can download and install. We also familiarize ourselves with the QGIS interface and also added spatial data while navigating on map view. And finally, we created our QGIS project and save our project on a known location for future use. Learning objectives from this module will discuss the definition and types of symbology, changing symbology for vector datasets, and saving your QGIS project. What is symbology? Symbology and geovisualization refers to the way each layer on your map looks, the different icons, their colors, and their size. Data layers form the primary building blocks in GIS maps. Within each layer, symbols, colors, and text are used to portray important information that describes each of the individual geographic elements. Symbols can be displayed as colored polygons, such as buildings and boundaries, point features for population census, hydrant locations, and linear features for roads and waterways, depending on the information that we want the users to see and understand. The symbology of a layer describes how the layer's data should be displayed on the map canvas. Map symbols. First, we will have a look at map symbols, which we are familiar with. Symbology, in the context of cartographic design, is the use of graphical techniques to represent geographic information on a map. Map symbols for geographic features include visual variables such as color, size, and shape for point, lines, and polygon features on a map. As we know that symbols helps us to know and understand what is present on the ground. As we had discussed that the symbology of a layer is its visual appearance on the map. This slide shows a map of the Samoa district boundary with tsunami sites that are located near the creeks and rivers. There are three different vector layers used in this map, namely district boundary, a polygon, tsunami sites, point, and waterways, line, with different symbology used to give the user the relevant information needed. It is important that your map symbology should depict the information that you want the users to see and understand. Map symbology represents the plot of a story, and we are trying to tell a story to the users of what the map represents through the different symbology used. Now that we have understood what symbology is and its importance, we will now move on to its application using QGIS mapping software. In this module, we will now look closely on changing symbology for the Vanuatu Efate datasets from Module 2. You will watch a video on the symbology application for changing layer displays, simple symbology for vector layers, symbology by attribute data, and applying transparency to our map layers in QGIS.
Now we are going to explore a couple of the other options. So if I go back to the polygon layer, right click on it, I'm also able to toggle editing, so I can begin editing the features within that data layer, and we'll do this in another lesson. I can also export the data set. I can change the color very quickly by going to this, clicking on the various values. You can see as I click around the colors, I'm changing the color of the polygon data. This is one way to quickly change the symbology for the data layer, but we can also open up the properties. And when we do this, we see a lot more information is available to us. The first tab gives us some summary information for the dataset, such as its name, where it's located on our computer, what type of vector data that it is, the shapefile, it's a polygon, it's in the WGS84 coordinate system, has certain bounding box, and the units of measurement are degrees, as well as the total number of polygons stored in the layer, which is 13, which we also saw in the attribute table. We can also go to the Source tab and see, again, information regarding the geometry and coordinate system. If we select the Symbology tab, here we can change the visualization of the data. So again, I can change the color. In this case, I'm going to make it red. And I can change the opacity, which is essentially to what degree is it transparent. So I'm going to make it 80% visible. And then I'm going to select OK. And now I change the way that the polygons are displayed within the map canvas. I can change the symbology for the point vector data in a similar fashion by going to the properties. In this case, I have a couple more options. I can still change the color, but I can also change the size of the points. So in this case, I'm going to change it to 3. And I can also change the way the points are displayed. So in this case, I'm actually going to select a blue diamond. And then hit OK. And now the point vector data is displayed as a blue diamond in the map canvas. I can also change the visualization for vector data based on fields in the attribute table. So for instance, maybe I want to go to the polygon layer and essentially change the way that the polygons are drawn based on their designation. I can do this by going up to the top in the Symbology tab, selecting Categorized, and what this does is it gives me options to choose which field to categorize the way the data is displayed. The first option we have is to select the field or the column that is located in the attribute data to actually categorize the data from, and this will be the designation field. Once selected, I can actually go in and change the symbology a little bit, where I can set, again, the transparency and some base colors or maybe some base designs. But for right now, we're going to keep it simple, and I'm just going to go and select the Classify button. And this is going to populate the legend with all the various designations located in the attribute table. For example, you can see Forest Conservation Area, Marine Protected Area, Marine Preserve, Recreation Reserve, and Reserve. I now can go and click on each one of these and change the color for each one of the designations. So maybe for Marine Protected Area, I'm going to select something along the lines of a purple color. And then I hit OK. And when I hit OK, what this will do is change the way the data is displayed again in the map canvas. So now that we're able to change the symbology for the data layers, let's add a little bit more information to the map canvas by including labels for each one of these vector data sets. In this case, I want to include the actual name of the protected area in the map canvas. So once again, I'm going to go to the properties. But this time, I'm going to go to the Labels tab. When I click on the Labels tab, the first option that I have is either to not have any labels, to include simple labels, or do more complex labeling such as rule-based, which we're not going to get into in this tutorial. I'm going to select single labels, and the first option that is presented to us is to choose which field that we're going to use to label the data set. In this case, I'm going to use name, which is the field that contains the name of the protected area. I'm going to go and change the text size to 12 points, change the opacity to 80%, and then select Apply. And now you can see that the polygons are labeled by the name for the protected area within the map canvas. These don't look very visually appealing, so we're going to go back and change a couple more options. First, we're going to open up the properties, go back to the label tab, and what I want to do is really make these labels stand out. So I'm going to apply a buffer behind it. We go to the buffer tab. First option is to draw the text buffer. I'm going to choose a color of white, so basically there's going to be a white glow around the black lettering of the label. Change the opacity to 80% to match the opacity that we designated in the text tab. And another option I'm going to do is change this wrap on character. And what this does is it looks for a very specific character, and when it locates it within the label name, it actually drops the label down to a new line. So what I want to do is just put a space from the space bar into this wrap on character. So anytime there's a space, it's going to make the label stacked, or it's going to drop the next word down into a new layer. The final option I'm going to select is to change the alignment. And I'm going to change this to center. And when I hit OK, what you'll see is that the labels will now be stacked, they'll be center aligned, and look much cleaner than the original labeling that we had designated. And select OK, and we can see that now the polygon labels are much cleaner looking. I'm going to do the same for the point vector data for the protected areas. So again, going in the properties, changing the label setting to single labels, labeling the point vector data with the name of the protected area, changing the text size to 12 and the opacity to 80%. I'm going to change the formatting where it wraps on the space character, and I'm going to set the alignment to center, and then change the buffer to white, so it will have a white glow with a 80% opacity, and then I'm going to select Apply, and then OK. And then for this particular island in Vanuatu, Afate, we now see that all the protected areas are labeled in a similar manner. Now that the data is displayed in the map canvas, we're actually going to save the project so we can work with it later. I'm going to go up to the Project tab and go to Save. And then I'm going to give a name for our project. So I'm going to use 2020 Vanuatu WDPA and select Save. And now our project is saved and we can open it up for future analyses. And to summarize, what we achieved in this lesson was becoming more familiar with the QGIS interface. We were able to load in data sets, both raster and vector, using 4 different types of methodologies. We're able to symbolize data sets in very simple color patterns, as well as stylizing the data sets using categories. We were able to explore the attribute table for vector data sets and some of the other properties. And lastly, we were able to label the data based on values in the attribute table and save the project for future use.
In summary, the basic strength of a GIS is having a dynamic visual representation of the data you are working with. Therefore, the visual appearance and symbology of the individual layers to be projected on a map is imperative. Most importantly, to produce maps with information that people will be able to use. To help us gauge your understanding of the module, we welcome your feedback and response to the following questions. 1. What is symbology and geovisualization? 2. What is one way that you can change colors for datasets in QGIS? 3. We can change symbology by attribute data, true or false. 4. Identify one label setting used in the video. This is the end of Module 3. Thank you.